In our previous video, we looked at some calculations that have to do with the mole concept. We looked at those calculations using the basic concept from mole, and we applied it to stoichiometry. Now, from the mole concept, we got this expression here. Now, we can also apply this expression in solving these questions. Now, it has to do with the reaction. From the reaction, we can write the balance equation to be magnesium reacting with hydrochloric acid to give magnesium chloride. Now, balancing our equation, we have one magnesium obviously, two chlorine is unbalanced, and at the same time from here hydrogen gas should be given off. So from here we can balance chlorine and hydrogen by simply bringing two here. Now we are concerned with magnesium. Here they give they asked for gram of magnesium, and here they gave volume of this guy in form of volume and molarity, so we can, it is easier for us to convert this to mole. We can easily convert this to mole. That is to say, we will leave the acid as mole and we'll convert this to gram. So it's volume to mass relationship. So from here, the mole ratio here is 1 mole of this metal reacting with 2 moles of this acid. So 1 mole of metal, the relationship between mole and mass here, mole and mass is molar mass. So we'll bring the molar mass of magnesium down here. The molar mass of magnesium is 24 grams per mole, but we just will not touch this. Means this, what is reacting here is 2 mole. The 2 mole we have here, so we're not touching this 2 mole. Now in order to know what's reacting here, we would say mole times molar mass should give me mass. So in doing that, we cancel mole, so it becomes 24 grams of magnesium reacting to give 2 moles, according to the equation, 2 moles reacting with 2 moles of the acid. Now we'll bring in the question. Now what is the question? The question says mass of magnesium metal that is needed to completely react with this. So the relationship from molarity, the whole concept, molarity will always equal mole over volume, and this volume, if in cm cube, should be divided by 1000. So if we apply this, we can say that mole becomes molarity times volume over 1000. That should give me mole. So because we have mole here, we can bring this value. Now what is molarity? Molarity given is 5. What is the volume? The volume given is 25 cm cube. So because it's a cm cube, we'll have to divide by 1000. Okay, dividing this and cross multiplying, cross multiplying will give me x equals total of 5 times 5 times Now 25 over 1000 should give me 0.025. Moving the decimal at the back of 25 to 1, 2, 3 places should give me 0.025. Then everything here times, so this should be mole. Sorry, this should obviously be mole. First of all, times, now this times 24 grams, then over 2 moles. Now mole will cancel mole, then 2 here, cancel this, that should give me 12. So this should give me a total of 1.5 grams of magnesium metal. Now let's quickly solve these other question. Question says calculate the number of carbon 4 oxide molecules liberated from the thermal decomposition of 12 grams of iron 3 carbonate. Now from the equation of the composition, we can say iron 3 carbonate will decompose to give a higher oxide, which is iron 3 oxide, and CO2. All right, we have the balanced equation. From here, iron is 2, oxygen here is 6, carbon is 3. Here we have 1 carbon, so we have to put 3 in front of this. That's 3 carbon. Now oxygen is 2 times 3, 6 times 3 is 6. Then 6 plus 3 is 9. Here we have 3 times 3, that's 9. Now the question is already balanced, so therefore it means here they give us give gram here, so it means we will have to quickly here we'll have 1 mole of this producing 3 moles of this. Here the relationship, here they asked for mass, they give mass here, so the relationship between mole of this and its mass is molar mass. So it means we will therefore have to bring in the molar mass of iron 3 carbonate. The molar mass of iron 3 carbonate should be 292 grams per mole. This is because the molar mass of iron is 56, so 2 times 56. That of carbon is 12, so, and that of oxygen is 16. So this will give me a total of 2 times 56 plus 3 times 12 plus 9 times 16. That will give me 290. So here they asked for number of particles. Here the relationship between mole and number of particles is 6.02 times 10 raised to power 23. Here to know what is reacting, we would say this times this, so that mole can cancel mole. This here is number of particles per mole, so the mole here per mole will cancel mole. Now this will be 1 times this will give me 292 grams, and 3 times this will give me 18.06 times 10 raised to the power 23 molecules of carbon dioxide. Now we can now bring in the question. They said here the number produced is unknown, and here they give us 12 grams here. So if this from the equation produced this, so therefore 12 grams should produce X, which is the unknown. So therefore from here I can say the value of X can be calculated as X equal 12 grams of Fe2 CO3 bracket 3 times 18 point, that should be 18.06 times 10 raised to power 23. Here this is on the carbon 23 CO2 molecules, all divided by 292 grams of iron 3 carbonate CO3 bracket 3, 10 grams of iron 3 carbonate here. Definitely I would cancel gram of iron 3 carbonates, and this will give me a total of, this will give me a total of 0.742 times 10 raised to power 23 carbon dioxide molecules, and that is the same thing as 7.42 times 10 raised to power 22 carbon dioxide molecule. So I believe this video helps. You can drop a comment, like, share, and subscribe. See you in our next video.